All right, you guys, let's have a seat. How's everyone doing today? What are we studying for? What are we nervous about? Oh, goodness.
What'd you get for
That's
bio?
stupid,
Serious
bro.
testing.
That's not fair. I hate geometry.
Why?
Because I got a
What?
out of 5.
No, it is.
It's just proficient. Should have been advanced.
Where is everybody today?
Oh, I don't.
Everyone's skipping, bailing on us. Good luck tonight. Away, right, versus Jerome.
Jake, what?
Home, Jerome. Good luck. Stick it to the rich kids. Right. Right.
No, you're not.
Come on over. Come on down.
Hair deck.
Yeah, for like the first 10 minutes.
Oh, it was a nice try. I applaud your effort. As you might have noticed, we're going to do a pair deck to kind of start off our day, kind of review what we did yesterday, which was what again? What did we talk about yesterday?
Cube.
Dylan says, I don't know. Cube what?
The cube graphy thingies.
The cube graphy functions. And one on cubic functions. There we go. Cubic functions. Not completely wrong. They are cubey things, but you know, we'll try to be a little bit more precise with our word choice, right? So if you haven't already, if you have a tab, go ahead and pull that out, phone, whatever you have. Remember, we're going to joinpd.com, and then your code, HYNJO. Hilarious yards, known as juicy olives. Yes, they do. Yes, they do. You guys are quiet today. Are we sleepy?
No, I'm
We
just
sleepy as we
focusing
were
on
yesterday?
studying.
Not really.
I hope not. It's Tuesday. Tuesday should be better than Monday, right? That's the goal. That's the plan. We've got 4 logged in. Joinpd.com. They'll probably make you log in with your school email. Initializing pair deck. Nice. Ooh, look at that 11. Ooh, give you a few more minutes to kind of get logged in there. We got 12. Anyone having trouble? You're allowed to ask for help. I'm allowed to tell you no, but you are allowed to ask for help. That was a joke. Failed attempt at keyword read. Keyword being failed attempt.
Alright. What is that? I'm advanced.
Okay, I'm going to go ahead and press
Yo.
start class. If you're not in yet,
Don't worry, you can still log in using the code. The code again is up top. Remember, we're talking about cubic functions in transformation form, right? That's what we studied yesterday, looking at those transformation forms. Put those away. We'll talk about our scores and geometry later. Can't do anything about it now, right?
Yeah.
So, tough. All right, let's look at question number 1 here. So question number 1, we're given the equation of our transformed cubic function. How do I know it's cubic?
Because there's just 3.
Because there's the 3 up top, right? So we've got 2 coordinate. So I'll give you your coordinate rule of your parent function, your coordinate rule of the parent, the transformed function, and then we're going to go ahead and try to graph that equation.
okay, remember if you're using your phone, you can change on the left-hand side the font size. You might want to change it to the smaller size.
Bottom left, I want to say once you do that.
Okay. Also, you can zoom in and out too as you need to. Some students last period were typing
On the phones, that seemed to be an easier way to go about
rather
it.
than trying to write with their hand.
And I don't even care if you want it on a separate sheet of paper, kind of write down some of the stuff or do some of the math. If it becomes a problem on your phone.
You also might want to have your calculators out to help you with some of the
Definitely would be a good check, right?
calculating or to get your points to your parent function. Nope.
H-Y-N-G-J-O.
Just turn it sideways,
I have it sometimes.
and then you can zoom in.
Yeah.
Yeah, then just hit the back button and then take that over. You can type two pairs if you want. The hardest part may be just writing the numbers on there.
I'm not going to judge your handwriting.
It says check your coordinate rule for your x's.
-3. What else is yeah.
2 minus 3.
Ben, looking good. Travis, one thing. Your parent points, check that last point on your parent table. I don't think it's 2-2.
And once you're signed up, it's your first Y value.
There you go.
Most of you seem to be doing all right. Make sure you're asking questions if you get stuck somewhere. I would use my calculator once I have that coordinate rule figured out. Be careful, make sure we're doing PEMDAS. So make sure we're multiplying first, adding and subtracting second.
Check your, oh, never mind, you're on it. Oh, I'm just watching the camera, it's right there.
Careful where it is
Swivl, your coordinate rules look good.
So do you have to grab?
Yep.
Now there is a negative sign, right?
It's gonna be the hardest part.
Like, it's gonna reflect over it.
To reflect over X.
Liam, you just read that, woo,
Oh, yeah, X values.
you're even using a Chromebook.
So it's negative X minus 3. You see that?
Red looks good.
You see that, Paris? Why that makes sense? Seeing some good looking coordinate rules so far.
Travis, one thing, the first Y value of your transformation points, can you show them that?
Yeah. So we plug -8 in to 3/4, we get what? Yeah, there you go.
Ellie,
Mhm.
for your parent function, the last point you have is 2-2.
Oh, 8.
There you go.
Oh yeah? That's what your graph looks like? It's a good looking graph.
It's messed up.
So you just scribbled over the whole thing?
Yeah.
Okay. Oh? Ooh, look at that. Well done.
So here, it looks pretty good.
Alright, what do we think about our coordinate rule so far? Anyone feel confident in their X coordinate rule? What is the X coordinate rule for this transformation? What do you think, Ben? Negative X minus 3. Everyone agree with that?
Yeah.
Negative X minus 3. I would agree with that for the X values. What about our Y values? Anyone idea? Ali, what do you think? 3/4 Y minus 7. Everyone agree with that? Hopefully that's what we got for our coordinate rules. 3/4 Y minus 7. And just be careful how we're plugging everything in.
Israel. Go check her coordinate rule for X. I think she reflected the wrong one.
This is another name, it's not the Y. That guy's inside of parentheses. So we'll go ahead and keep that with X. Hope, we ready to fall asleep over there?
No, she just,
Zoned in. Really want.
What do you have to?
Fall asleep.
so tiny.
What do you have to?
Yeah, I can't even imagine doing that on the phone.
The
That's
first
why I'm
one
not running this game
is
with you
this
guys.
one, and then the second one's that.
Oh yeah, you don't have to draw the parent function, Dylan, but that's fine.
Oh.
That's fine.
Hey, way to go above and beyond though, okay?
Yeah.
That's just my job.
You even got it through the 0, 0. Oh, look at that. Ms. Allison, you want to throw some for on a shared screen? I think this person here was trying to. Okay.
Oh, shoot. I got you.
You got
This is
me?
wrong.
He had graphed the parent function.
He's grabbing the back. Going above and beyond. Let's see what else we got here. I like the corner rules I'm seeing here. There's a good graph. I'll take that one there. It doesn't have to be perfect. We're using our phones. I know it's not going to be perfect. I like to look at this graph. I can see where that S bend is.
Some people didn't even do
Well, that's
it.
another good one. So remember here, for our parent function, 0, 0, what did we call that point? It had a special name. What is it? Say it loud.
Reflection.
A point of inflection, right? When we were crossing that 0 point at a hard angle, almost at that S curve and then coming right back up. So we should see something similar to that. It's the same point of inflection, it's now just shifted down here to -3.7, okay? And that's where that point of inflection occurs. All right, so we should, hopefully when you're drawing those graphs, that point of inflection, that's that key point. You want to kind of get that shape going with that S curve, okay? Everyone feeling pretty good about that though? Seeing the graphs, we feel okay? Ready to move on to the next one? Not terrible, be careful with the straight line, just because it wouldn't really have that sharp 90-degree angle, but I get what you're trying to do. And my guess is the phone more than it is you. Blue dot. I don't know what that's for.
Straight line.
Ooh, smell it there.
Wow.
Well done. It's all
Good
right.
job.
Okay with it?
I drew the other one.
Do I hit end here?
Yeah.
Move on?
No.
No?
What do you want next?
Ready for the next one, guys?
You're so small.
All right. So this next one here, you're given the graph. We've got to come up with the equation, right? In case you forgot what our transformed equation looks like,
It's not
our
loading.
transformation equation's up here for your assistance.
It's not loading.
It's not loading, maybe try to refresh it. It won't kick you out, you'll just be able to come right back to that page. Sometimes it gets a little stuck.
Yep.
If you're having trouble seeing the graph up top, it should come out a little bit easier on your device. What do we got to solve for first as we're doing this?
Slow.
Be careful, it's not slow.
Oh.
A, what does that A value represent?
Oh, vertical thing.
A vertical thingy? Who said it? I heard it.
Stretch.
Stretch or compressions, that's where that A value comes into play, right? So we gotta make sure we're trying to solve for A first. Hint, hint. Did a lot of this hopefully yesterday for our homework.
Oh my God.
Not enough space? If you want to do some of it on a separate sheet of paper, I'd be okay with that.
Oh, you don't read your cubed in there.
Ooh. Yeah, we still gotta make sure we're cubing everything. That's how we know it's a cubic function, right? That little 3.
Oh. What's 2 minus 3? What?
What's the point on the graph?
Look,
Let's say negative.
the x minus 3, right?
Geometry.
Using text box. It's easier.
Okay, raise the power of 2 is raise the power of.
What do you mean all these things?
Oh wait, you already
Yeah, I already told you.
Dylan, did you already find the A value? Solve it, plug it back in?
Yes, but Dylan, your HK point is not the correct point.
Oh no!
Did I switch it?
Yep. Remember, what's your point of inflection?
So that goes in for our HK.
Oh, I
Aiden,
thought
make sure you put cubed in there.
Oh, I put square.
Your left hand
What's
doesn't
up?
really change your answer, but
Point
the
of
equation should
inflection.
be cubed.
So remember, what does our HK represent in a quadratic?
On the point of.
You just want to check your HK point.
It's Not the point, that's in a cubic. What about a quadratic? The vertex, right? Our HK was our vertex. That was the special point in any of our quadratics. With a cubic, that special point is, now, say it.
Point of inflection.
There you go, the point of inflection. So the point of inflection is what we are using for our HK value now.
The H is still.
Oh.
what's it called?
Let me erase this.
Still the opposite.
Oh, you're working.
It's-
X minus H.
But H is X. What?
H isn't the X value of the
But
quarter
like
point.
the X of the
Of the point, yes. Yeah. H is still X, K is still Y.
Because you're going left, right for H and K is up, down, so
Yeah.
that's your X one.
You forgot to do that one thing.
Floor looks good, just don't forget your cubes and your names.
Couple cigarettes.
Yeah. Sometimes you get mix up the points and still come out okay, depending on what the points are. Doesn't mean it always.
No, almost right.
Yeah. And I had to take off points. I don't want to do that. Not if I can help it. How we doing on this one so far? Looks like we got some people getting close.
Then why'd you put a negative inside? Not, don't do it, yeah, so that would be it. We would use that as an A value, not an B. Remember, we always have equal one.
Yes.
Fair, be
What's
careful,
up?
should be two negatives.
So,
Yeah, because it's.
you upset?
The
Because it's
opposite, right?
X minus H, right?
Yeah.
And H is 3, so it should be X
I
minus
have to show
3.
my work.
You just did right.
Oh, isn't
3.
3 negative 3 for like the opposite?
No, 3 is positive in there. I don't see a negative.
Not the negative.
It's positive
Oh,
3,
the other
negative
one.
8.
I'll do the other one.
You didn't show on screen.
Okay. So we're going to use 2, 3 as our XY point. It's a random point on the graph. We're going to use 3, negative 8 as our HK because it's the point of inflection. Oops, negative 3. Okay. So we plug those in. We should end up with negative 3
There's some different ones up here.
equals A. Let's see.
Like the, wait.
Ooh, I like this one. Thank you for typing it. It makes it a little easier to say. So negative 3 equals A times 2 minus 3 quantity cubed minus 8. Make sure when you simplify that inside our parentheses there, with 2 minus 3 gives us negative 1. We're cubing negative 1, which is going to give us, what is it? 1 or negative 1? Negative 1. The signs stay the same when we cube things, right? So we have negative 1, and what happens to that negative 1? What's the next step? Timesing that by the A value. I saw a lot of mistakes in the first period where people were taking that negative 1 and right away subtracting 8 from it. That 8 has nothing to do with the A though. We've got to do multiplication first. So negative A minus 8 equals negative 3. We add the 8 over, divide by negative 1, we end up with A equals negative 5, and we plug everything back in. Right?
So once you get that number, notice this person put that number in front of A, makes it a little easier to.
Sorry, I scrolled down too soon.
Oh, you're fine. But notice he put that negative in front of the number, or in front of A to remind him that that's being multiplied by A.
I mean, way to use your
We got
space.
there. We got the A.
You scroll down to the over.
Be careful here. We don't want to flip this. We're going to keep A as a whole number. It should be 5, negative 5. Pretty good one there. Oh, and they gave us some descriptions to go with it. I like that. Is that just because we got bored? Yeah, I'm okay with that. Test your knowledge, right? Nice job. You guys did a pretty good job with this. Everyone's feeling good about it? I like the blue. Got to change it up with some
Yeah.
color, a little flare.
Text box, the way they get it.
I like the label and point of inflection, interest, inflection.
Still got the right answer.
Oh, that's nice.
Oh my. What? I don't know what that is. Interesting. Interesting. Anime. Okay. One last question there, coming up on your screen. I want to know how you guys feel about what we've been doing working with transformation. Do you feel good about it? Okay, meh, or sad face? Frowny face. How are you feeling? Circle it, save it.
Just about qubits, transformation to qubits, is what we did yesterday.
Yeah, not about, man, just how your day's going so far. I've had a bad morning, so I'm terrible at math now. And I'm going to start passing out what we're going to spend a little bit of time on today. Shouldn't take too long. Four, two. You guys have got me so nervous about counting because I always mess up. Too many or too few. Oh, you seem way too amused at my mistakes. Okay? Whatever we should do today. You have to make fun of me to get through the day, so be it, I'll let it.
What are you?
All
Oh
right,
my
so we're ready to
God.
switch gears here just a little bit. Kind of, sort of, not really. We're still dealing with cubics. Cubics aren't going away. And remember, we're studying cubics most of the week. And then as we get into next week, we're going to start looking at some higher order polynomials.
Can we leave the paradigm?
Can we what?
Can we leave the paradigm?
Can we leave the paradigm? How so?
It's a question. Yeah, we're done with it.
Yeah, we don't need the paradigm anymore. Yeah, we're done. Yep. All right, you guys, so we've got up at the top cubic function investigations. It tells us, remember we always want to read our directions,
Well,
figure out what we
their
want to
directions are a
do.
little different.
All your directions are
Yeah,
different?
yep. Sorry.
So, biggest thing we want to be able to do for these graphs, we want to be able to graph them, quick sketch, right? Talk about our domain, talk about our range, talk about our end behavior, identify any maximums or minimums that may appear. In the parent function you worked with yesterday, we didn't see any maxes or mins, but as we look at some of the cubic functions we're going to see today, we will, okay? And then identifying the zeros, okay? Identifying where those zeros are, and we're going to do that for each one of these functions. Now I'm going to skip x cubed here because we did that one yesterday. That one hopefully is looking very familiar to you because we did that yesterday. And we'll kind of do this second one here together. First thing I'm always going to want to do, x cubed minus 5x squared. I don't know what that looks like off the top of my head, right? I've been doing math for too long, 20 years of math class, okay? And so I don't expect you guys to either. Use your calculator. So we go into our calculator and we say, hey, y equals x cubed minus 5x squared. We go ahead and zoom 6 of that. And as we zoom 6 of it, it'll pop up as it's thinking, it's thinking, it's thinking. Ah, crap. What do I gotta do? We gotta zoom out, right? We don't like this window. Why not?
It doesn't show the point.
Yeah, there's some sort of minimal possibly going on here. My graph goes down and then it comes back up. Let's see if we can find that turning point, okay? So we'll go into our window and we'll adjust our zoom down. I'm just gonna adjust the y values down to -20 and see what that gives me. Again, that becomes just a really guess and check. But -20 might work for us. And it does. Woo, got lucky on the first try. I like it when that happens. So we can see here, we've got, I definitely see a couple zeros. I see a min, I see a max. What kind of mins and maxes are those?
Local.
Be careful. I heard global and I heard local. Which is it?
Local.
Local. Remember, global means it's the absolute highest point on the graph, right? Why don't we have any globals here?
Because it goes to infinity.
Yeah, we go up and down forever in both directions. There are no global mins and maxes unless you can count infinity. Can anyone count that high?
No.
I can't.
Of course.
Of course, you're going to spend a lot of time trying to get there. Let me know when you do, okay? You let me know. And then we'll start inventing numbers as you get higher. You know what I mean? That'll be fun. Could be an interesting IA on that one day. Let's talk about zeros here. I see one of them really clearly. Which one do you guys see?
0, 0.
0, 0, and 0, 5. How many zeros should we have? 3, right? It's a cubic function. We need, hopefully we can see 3 zeros. Say it loud, Hope.
0, 0 is a double 0.
It's a double zero, right? Remember we talked about that with quadratics yesterday. When we had that quadratic and it barely touches the line that's tangent to the x-axis, we count that as a double root. Same thing with our cubics here. So as this line approaches 0, 0, it touches 0, 0, and then comes right back down, we're going to count that 0, 0 twice. So as you're labeling that 0 on your graph or on your piece of paper, you might want to make a note off to the side. Yeah, 0, 0 is a 0. 0, 0 is a 0. It's also a double root, or it has a multiplicity of 2. It shows up twice. You want to make a note of that. Yes, sir.
How would be the triple zero?
Well, do we have? Where's the third one now?
5.
To the right of 5, 0. So we're not going to have 4. Now the triple zero occurred. Does anyone remember when? Happened with our parent function, right? Where did we see that triple's root?
What does it look like?
Yeah, when the point of inflection is our 0, that counts as a triple root. So when we have that S curve that's curving in right at the 0 and coming on up, then we can count that as a triple root. Good question. Good question. Okay, so everyone sees that? We've got 1, 0 at 5, 0. We've got a double root at 0, 0. And then let's go ahead and look at trying to calculate our maxes and mins, right? We can do that pretty simply on our calculator. Second count, we'll look at the max first. Second count 4. Scroll slightly over to the left for my left bound. Come back over on the right side of the curve for my right bound. Hit my guess. And it tells me my maximum is at negative 1.72 e negative 6. And the y value is negative 1.49 e negative 11. What do we think? Should I write down those decimals?
Yeah. No.
Absolutely?
Yeah. Wait.
Uh-oh. What do you guys think?
Wait, what's the question again?
Where's my 0 at here? Is it at negative 1.72, negative 1.49? Is that what that point is?
No, that's the all of the.
Yeah, what's that e do?
I like the mistake.
Yeah. So when we have an e value that's really big, e negative 11, e negative 6, remember that's telling you you have on the x value 6 zeros before you get to the decimal, and the y value you have 11 zeros before you start getting to the decimal. Okay? So it's really, really, really small. It's really close to 0, and we've got to be smarter than our calculators to know, hey, that's 0, 0. You can also just look and say, hey, I'm at 0, 0 on my graph.
As
right?
he's going through this problem, I would be sketching your graph on your paper. Remember
I'm
to
doing
do
one
the
of these
second
for
one,
you.
and labeling all this information. You can either label the graph itself, or some of you like to list it off to the side. That's fine too. Okay? Whatever you prefer.
Now one more thing to find here. We need to find the max. Uh-oh. Well, I found that. That'll work. 4 for my right bound. And we'll guess somewhere in the middle. And it's coming up with 3.33 and 18.51, negative 18.51. Call it negative 18.52 if we round. And I'm okay with that, right? There's no, we're allowed to have fractions and decimals in the max and mins. It just so happened our first one was actually 0, 0. This one we can trust, right? And you could give me that third as a fraction. You could call that 3 1/3, however you want to do it. Okay? Everyone good with that? Finding maxes and mins. We've done this several times. This is nothing new, right?
Yes.
Let's go ahead and look at this graph then for end behavior, right? I always like to start going on the left. So as x approaches negative infinity and goes to the left, what happens to our y value?
It goes to negative.
Yeah, it's going down forever, right? So as x, can I write on this? So as x approaches negative infinity, f of x also approaches negative infinity. My infinity signs are so much worse than yours. What about as we approach to the right? As x goes to positive infinity, what's happening? Yeah. Y is also going to positive infinity. What do we feel about our domain and our range here? What's our domain for this function?
Negative.
Yeah, all possible real numbers, right? We can plug in any x value, we're going to find an output. What's that mean our range is going to be?
Same. All.
Yeah. All
So
possible
as you're sketching
numbers.
your graph, what do you think you should put on your graph that your calculator's lacking? Luke, say louder.
Arrows.
Arrows.
Don't lose a half point on your quiz because you don't put arrows. It's the easiest and like evilest half point I can take off, but we're still going to do it.
Aiden's gonna be mad.
Eight's going to be really mad. Was that all you missed on that one? Was
No,
that?
we missed the plus or minus sign.
Oh, dang Dang it. We are going to give those back today. Happy day. And remember, so since we brought it up, so we'll pass back the test today, right? Look over that. Remember, we have that end of quarter test possibility optional to you, and we need to know when to get that turned in. When do we need to know about if you're taking that? Friday, right? So we'll give those tests back. That'll give you a few days to look at it, decide if you want to retake anything, right? And we need to know that by Friday so we can get that test to you Monday or Tuesday. Good?
So if you know today you're going to retake it, just let us know.
Yep.
If you want to kind of wait and see and decide, you just got to let us know by Friday. It's going to cover both tests, so make sure you look at both tests, because if you don't look at that first test and you go in there that quarter test and you bomb it because you didn't look over that first test, remember that's great, it's still going to replace your lowest test grade.
All right, so we talked domain, range, and behavior, zeros. Did we get it all? Max and mins? I think we got it all, right? So the rest of the day is kind of your day. This worksheet's going to be due for homework. The good news is you got plenty of time to get it done. Make sure you're asking questions. Use your calculator to help you, okay? And we'll start passing out some of those tests and quizzes and worksheets that we have, okay? We didn't do, yeah, we did. We did it quickly.
We just did-
What's our domain? What is our domain? What's our range? That's how fast it was. That's why you probably missed it. Sure. I won't hold it against you.
So notice this worksheet here, these are all cubic functions. What form are all these in? Standard. That's why we're using our calculators to help us graph, because it's missing some, it doesn't really give us a whole lot of information. So keep in mind when you come in on Thursday, because most of you won't be in class tomorrow, okay, we're going to go over this. So if you notice on the very back, on the bottom there, what's it asking? On the back, on the bottom. Right, so if you're working with partners, you can work by yourself. Some trends, some patterns, right? So make sure as you're going through this, yes, it's using your calculator, but start to notice some trends and patterns of these cubic functions in standard form. Okay, so when you come in class on Thursday, that's the first thing we're going to do is we're going to go over questions, some patterns that you've noticed, and then that's when we're going to study that last form, which is the form we have not looked at yet for cubics.
What form did we do yesterday?
Don't call it vertex anymore.
What are we calling it? Why don't we want to call it vertex form? Because there's no vertex in the cubic. So we don't call it a point of inflection equation. What do we call it? Transformations. Yeah, Floor. So remember, we call it transformation form because they will apply to any and all functions. Vertex form is kind of specific because we can't always use a vertex here. And then today, what's this worksheet going over? Standard. So what's the last one? Factor form, being able to find the zeros just from looking at the equation. We'll look at that tomorrow. Okay? So in other words, make sure you answer the question on the back of the page. Don't just ignore it because it's making you write the answer. Heaven forbid it would make you write down sentences in math class. Yes, sir.
Yeah, I'm just curious to see what it looks like. It's just yours. So it has the question and then it has your response.
Yeah.
Okay, perfect, thank you. I was curious.
No, right? Because we don't have any turning points. Alright, so there's no place where it goes from increasing to decreasing.
Oh. Those arrows that get you. I'm gonna turn the light on.
I can't see.
There's only two. Technically, we didn't take off your real parts of the first and the imaginary parts. Notice here it's real and imaginary for a complex number. Good habit to get into. But we didn't take off. Yes.
What is this?
I turn my calculator on, so
Dylan, you okay?
it's the plus 1.6 times.
Oh my
Yep.
god.
Oh,
what are we doing?
It was 0, 0. Yeah, so that's already in scientific notation.
47.
It's like 0.0000000, there's 11 zeros at rotation numbers. So you probably got like an E on your calculator. You just have to know that that means that next closest number would be considered. On the review. This is the review, yeah.
It was out of 6 points, I think.
Yeah.
We gave you a little bit more because it was a bigger packet. I think we did like 2 pages a page. Sorry, I thought I lost you guys. If you have questions about anything on your test, don't hesitate to ask.
That's
The world is still shining, right? The sun is still shining, the world is still turning. We will be okay.
He said skip it.
She's not here.
Excuse this interruption. All students coming to the Columbus State field trip, please come to the front entrance at this time. Thank you.
I'm failing right now, I apologize, guys. So you say you're taking the quarter test for sure? Is that something you still want to think about?
I'll probably take it.
Ooh. All right, you want me to write your name down?
Sure.
Taking it?
How'd
Do you have a time, first or second, or Monday or Tuesday when you want to take it?
What do you got?
Oh, that's so bad.
5, right?
Dang, Lord.
That's because he takes like 20 minutes.
I would say probably both.
Yeah, you should be getting perfect scores. That shouldn't take that long.
Or you can do it after school.
Yeah, you're right. You do take this off.
I know, I told you.
Little arrows right here.
Well, I don't care about the corner plane.
Oh shoot! I
And
the arrows just to point the
I've told you guys about arrows. It's like the one thing I've highlighted, hint on like every day.
Yeah, I put arrows.
I did it again today too, didn't I?
Wait, what's wrong with this?
You dropped your 6 down. Reduced the 2 out of your
And then
6.
in the meantime, if you have questions, you'll be in your phone.
I think you made it a 3 inside or something like that, or a 2. You did something weird. Yeah.
So just forgot to put a 6.
Yeah.
Oh my god.
That's why you only got about half point off.
For the most part, you'll have some assignments, some like you'll come up here, a little bit more.
Do this worksheet.
All the pages.
Just remember.
Oh, it's gonna take
Is that all you have to do?
Yeah, it's just write a graph.
Jaden, you said third, right?
Can you factor?
Jaden, third,
Yeah.
Tuesday, Monday, Tuesday.
Tuesday.
You could try it that way, but then you'll find out it's not factorable. And that's where you, when you do that, you
Think
gotta use
I'm
quite a
banging
bit.
on my chest.
Everybody doing okay still? Surviving? If it's factorable, do you know how to factor that?
Yeah, we could have factored this.
Okay, you take an X squared out with your left hand side.
X minus 5.
I mean, your test out.
Because we're not doing a factor formula.
Oh,
We're
shoot,
going to
oh.
do, we're actually going to do fractions Thursday, but we're going to factor them all out. So we're going to show you the same equations if you can factor them, how we'll do that. Yes, sir.
So every function has 3
Yes. Correct. Sometimes you can't see them all, right?
Okay. Make sure you look over the. And look, the idea is we're not trying to.
Maybe you say like one real, and then if you can't see them on the graph, maybe there are some imaginary ones you don't know, right? Right?
Now we're happy. Okay.
All right, Luke. Hope, surviving.
Hi, Jaleel.
Says, yeah, I don't want homework tonight. Get out of here. Leave me alone. Ellie, surviving.
Wait, what did you? How do you show the?
So what do we call that thing, right? That's the point of inflection, right?
Yeah.
What do we call that?
Make sure you look.
What kind of root is that?
3.
Triple root. Yeah. So when your point of inflection happens on the x-axis, we call that a triple root. So 0, 0 is your only 0, but it counts 3 times.
I've fallen and I cannot get up.
Do you need help?
Oh, no.
You said you've fallen and you can't get up. So I was coming to assist you.
Like the old lady. Yeah.
Life alert. You know, the new Apple Watch is supposedly have that feature built in, where that if you take a steep fall, it'll automatically, like, it'll buzz you to see if you're okay, and like ask you, are you okay? And if you don't respond, it calls 911 for you.
Good stuff. It's crazy,
Now, how about this? It only is activated if you buy it and you're above a certain age. The feature's on every phone, but it's only automatically activated if you're above a certain
That's
age.
creepy.
A little creepy, right? Creeps me out too. Apple's invading our lives.
Well, if you just take a nap, it goes off.
I think it's not about you falling, it's about the actual fall. It can somehow detect when it's at a certain height.
Like if
and
you
all
go
of a
like this,
sudden drop.
Show what
Right.
there's in though. What if you like?
Some guy was actually like testing it like a professional stuntman to see if it actually worked.
What if you just go like-
he actually fell off.
Yeah, yeah.
Okay. The max. So
You have a maximum in there? There's no turning point. Like here we have a turning point. So I'm here, I would just say no max, no min.
Domain or
The
image
key
or
features,
feature.
and look at the directions. And as you're graphing these, if you notice patterns, feel free to go ahead and add those on that
Now
back
be
there.
careful. Are you on it or direction to the left?
Ooh,
Hey, Dylan.
But that's the problem.
Look at this.
So if the calculator does this is before sign change.
Oh, wow.
Zeros happen, negative more values.
For the first one,
Cross that x-axis, that's what your calculator
I don't know.
Oh, no, there's the actual.
So your calculator right now is above
That's
it,
actually kind of.
and then even if you go to the right, it's still above it, and that's where you're.
I've never played Fortnite, so.
That's why it says no sign change.
I don't play
You're
that
still
much.
in the positive, you know what I mean? So when we do this, we just gotta make sure that.
We get like, you know my geometry class.
you're above it.
Oh yeah, because you always play Fortnite.
And then for the next one, your left bound, this one in the middle, is gonna be above it, below it.
I was in Lincoln on mental.
Oh yeah, but you always come over to our class.
Yeah.
Okay, so that's one.
Joe expanded class.
Your class was pretty cool.
That's just good.
Because, yeah, this is 24 and
Surviving, gentlemen?
Yep. Yeah, we're gonna flip to the back. So
Where's the bonus?
Oh, this is.
I guess 100 number 5.
Now here my question to somebody was, because they asked it, it's always the same. I wondered if there ever be a case where we could reflect it over something where it's going sideways instead of up and down. And then if it were to go sideways, would that change it? You know what I mean? Something to think about. What's up, Ellie?
When you like put it in, are you supposed to put parentheses or no?
You don't have to.
Okay.
Yeah, you don't have to. It'll still work if you do. That's fine.
Oh, okay.
Yeah.
It looks confusing.
Well, it's just we're zoomed out a little bit.
You get what you put him in.
Oh, it's pretty close.
He says you get what
Should I like change the window?
You can. I might leave it as is just because.
you get.
Oh, you know what? Let's see. It might actually change this a little bit.
There we go.
Yeah,
So
you know what? We
should see
don't want the
intersecting at
parentheses
24.
because we're not
Why is it?
cubing the 2's.
Oh, really?
Or we're not squaring the -2. We're just squaring the x value. You know what I mean?
Okay.
So let's see how that changes here. Looks a little bit different there.
Yeah.
Before we weren't coming in, we were coming in at a decimal there. Now I think we have a solid point we're going through.
Okay.
So yeah, you don't need parentheses like for that third equation there, 2x cubed minus 2x squared minus 24x, bless you. You don't need parentheses around the 2x. If you do that, you're going to end up cubing that 2, which we don't really want to do. We want to keep that as 2x cubed. We're cubing the x value, not the coefficient.
What is this?
Travis doing all
Right
right?
now, there's just after for graduation, yep. They might eventually change it, but that's now.
Before we got
All my infrastructure, I've just gone through.
Yep, but you still will have to be required to take.
Oh, is your Megan? Good morning.
Is it hard?
Okay, they call you
Like technically.
He just continues
the
working.
football coach is like
He studies.
Yeah.
So,
They're just
Chad
professionals.
Jordan.
I guess I was always known by my last
You would have been
name.
at our table.
Dude, you have like a 24-page thing.
I mean, it's like 16 pages
Honestly, it's
less.
bad.
But
It's
like,
not worth it.
Going too fast, huh?
you could say it would be all me and Civil. Or me, all me
Yes,
and
it
Adam.
is.
Either one of us. Because
How'd
I
you
think
do, Ollie?
okay. You're
I could whack the shit off
We
you.
got facts. We did pretty
No,
well.
because everybody in
Touche. Well,
their
no,
table has like a 70%.
Oh, 70%.
Well, like, no, no,
That really makes you
no, no,
worry.
Still got about 4 minutes, gentlemen. Plenty of time to knock this out so you don't have homework.
What?
Right, David? Or you could do homework because,
Actually-
we don't have anything. Oh my goodness. What have you been doing the last 10 minutes?
He's like,
Looking at Fortnite figurines.
That's not a waste of money at all.
I did that. I did that.
No, the game's dead.
The game Fortnite is dead?
Yeah.
no, it isn't. No, it isn't. Who said that?
I stopped playing it 2 months
Yo,
ago.
he's gonna fight you.
I stopped playing it.
Boom.
I never played it.
Miss Allison's cooler than the rest of us, that's for sure.
Call of Duty Black Ops 4. It's gonna.
Well, then you got Red Dead Redemption coming out. There's all kinds of things that are going to take up time.
Redemption? I thought that came out when the one.
You're gonna hold it. Second one, you dummy.
Second one coming
I
out.
know, that's what I'm saying. I thought that, like,
And
been
looking at it,
8 years.
yeah, it's been really long since. It's been long overdue.
I'm hoping, by the way, some of us are rolling, don't have questions, right? Everybody feels good?
Sir.
We're going to come in tomorrow with this worksheet done, those of us who are here, because most of you will probably be where?
PSAT.
PSAT, right? Don't forget about your PSAT. No working Wednesday tomorrow, right? Be here on time. I know you've heard it all morning. You're going to keep hearing it. Be on time, 7:55 tomorrow.
Make sure you guys take your calculators to the PSAT.
You hear that, Ekis? To here? What do we need to take tomorrow to the PSAT? Use your calculator. You guys have learned a lot of cool tools with your calculator. Be able to find the zeros. That can help you factor, right? Use that tool. Right, David?
I mean, I'm not doing that.
Why not?
Because I'm a
Sophomore. Thank you, Ellie, for letting me use this.
Have a great day. Good
The
luck
camera is
tomorrow.
following me.
Good luck. Sleep.
Once you move.